Hello and welcome to a lesson on networking. And for those who are beginners to networking, this is an introduction. Core essentials of networking. This is a diagram of a simple network program. A simple network program consists of two parts, a server and a client. The server program must be started first and waits or listens for the client program to connect. On the left is the server, on the right is the client. And the server must be started first and waits for the client to connect. Reverse connection RATs, remote access tools. It is also possible to have the server connect to the client, as in the case of a reverse connection RATs. Reverse RATs are used to bypass firewall or router limitations. Normally, those computers that are sitting behind a router or a firewall cannot be reached from outside because the firewall will block the connection. So in this case, if you are planning to target a particular machine inside, after you have managed to infiltrate through phishing attack, for example, to install a RAT in the server, then the RAT will initiate the connection. For example, if it uses port 80, the firewall usually doesn't block port 80. Port 53 also usually doesn't block because port 53 is DNS. So this is an example of where you might use reverse connection RATs in order to penetrate the firewall. Location of server and client. Usually the server program resides on one computer whilst the client resides on another. However, both can be on the same local area network LAN or on the internet. Also, both can reside on the same computer for testing purposes. Remotely executing commands. After the server and client has established a connection, the client will send a command to the server. Upon receiving the command, the server will execute it. Example commands are, for example, to display message hello world, beep, shut down, reboot, activate hardware, create file, delete files, run programs, and so on. In short, any command that could be ordinarily executed by a user sitting in front of a computer. IP addresses versus port numbers. IP addresses, also known as Internet Protocol addresses, are the address of the house. Port numbers are the people who live in the house. IP addresses is the address of the computer. Port numbers are the server processes running in the computer. There can be more than one server process running on a single computer. Therefore, for each IP address, there can be more than one port number. For example, on this machine here, it has an IP address of 192.168.1.2, but it can have multiple port numbers because there can be more than one services running on the computer. Each service uses a port number. Port number 21, for example, 25 and 80. 21 is the FTP server, 25 is the SMTP server, and the port 80 is the web server. Local area network versus internet. IP addresses, for example, 192.168.x.1 to 192.168.x.254 are reserved for LAN use. The X here refers to numbers from 1 to 255. There can be other range of internal IP addresses as well. This is only one example in the class C range. There can be class 1, class A, class B, and class C, and so on. There's a special IP address known as 127.0.0.1, which is also known as the loopback address. It refers to the local machine, the local computer itself. For the internet, the IP addresses are assigned by your Internet Service Provider, ISP, when a user connects to the internet with a modem. Therefore, a computer can have multiple IP addresses. Each IP address will be bound to a network interface. The network interface is your network adapter. Port numbers, also known as sockets. Port numbers can range from 1 to 65,536, but the port numbers 1 to 1024 are reserved for special use. For example, 21 is File Transfer Protocol (FTP), 23 is Telnet Server, 25 is SMTP for email, 80 is HTTP, also known as Web Server, and so on. Any number above 1024 we can use for writing network programs. But before you actually use a port number above 1024, always check first to make sure that it is not already in use. Checking IP and port numbers. So this is how you can check. To see the IP addresses and port numbers on your machine, first open a command prompt and issue the following command: netstat space -TAN. TAN here refers to the options TCP protocol. A means all, N means in numerical form. That means in IP address. Do not try to resolve it to names. You should see something like this. So here is the output of a command prompt where I've already typed the command netstat -TAN. In the first column is your protocol. There are two kinds of protocol which I will explain later, TCP or UDP. And then the second column will be your local address. 0 means any IP address. That means it is bound to the local machine. Whenever any incoming connection comes to this machine, it will be bound to the local machine because of this 0000. Then separated by a colon is your port numbers. So these port numbers are unique for each service that are running locally. These are all services. And then here are the foreign address. That means computers which are outside your computer, outside your network, or it could also be in the same local network but on a different machine. Trying to connect to your computer, but at the moment if you see zeros, that means there are no connections to these services. And then on the fourth column will be the state. It can be either in the listening or established and so on. And the last one you can safely ignore it. And you will see here this row here, there is a connection coming from your machine going out to the internet, to the IP address shown here at this port number 443. Differences between TCP versus UDP. TCP stands for Transmission Control Protocol. It is a protocol used to establish connections with other computers on the internet or even in a local area network. When a client wants to talk to a server, it will follow the protocol of TCP to try to establish a connection first. If a connection is established successfully, then the client and server can talk. So this is an example of an output where you can see the first column TCP and below that you can see UDP. I'll be explaining UDP next. UDP, on the other hand, stands for User Datagram Protocol. It's another protocol used for communication on the internet or even in a local area network. But unlike TCP, the client need not establish a connection with the server first. The client just sends the message, irrespective of whether the server is up or listening. However, if the server was not listening, then the message will be lost. So what is the difference between the two? What's the advantage? When do we use TCP or UDP? TCP is used when you want to have a reliable communication. For example, if you are transferring a large file, you want to make sure that the file is transferred bit by bit and arrives safely without missing packets. then you will use TCP. But TCP is slightly slower than UDP. UDP, on the other hand, is suitable for very short messages like DNS queries and so on. So when you're trying to query for the IP address of a host name, then you will use UDP over DNS service. TCP/IP protocol. Both TCP and UDP belongs to the TCP/IP protocol. Note that the IP address is followed by the port number and separated by a colon. Take a look at this screenshot here. In this row here circled in red, you will see that this machine is running a service called the NetBIOS service. NetBIOS is used for Windows networking. It is listening on port 139. Any number less than 1024 is usually a service, a server that is running. And then in this column here, there is no connection to it yet, so you see all zeros. Note that the IP address is separated from the port number by a colon here. So in this case here, 192.168.0.114 is the IP address, and port 139 is the NetBIOS port used for Windows networking. The need for client port numbers. Note that clients also need port numbers and IP addresses. Consider the connection outline in red here. You will see here that your machine is using port 54116 to connect to another remote IP address in the internet with this address and having the port number 443, which is also known as an SSL port, Secure Socket Layer. This port number 54116 is dynamically assigned by your operating system. But port 443 is a well-known port number for SSL. It's a server running SSL. So any two machines which want to communicate must have two things: IP address to identify the machine and port number to identify the process which is going to communicate. The local computer with IP address is 192.168.0.114 is using port 54116 to connect to port 443 at the remote IP 20.198.162.76. IP addresses versus port numbers. This diagram here shows two different computers. On the left, we have a computer with the IP address 192.168.0.114, and on the right we have another computer 20.198.162.76. This machine is typically a server because you can see the port numbers are well-known port numbers: 21 for FTP service, 25 for SMTP or email, 80 is for web server, and 443 is for Secure Socket Layer, SSL, which is also a web service but running encrypted over the internet. And on the left is your machine. And typically your machine is also known as a client machine because it is trying to connect to the service on the server. That's why it is known as a client. And normally the client will have a big number above 1024. As you can see here, there are many processes with big port numbers, and each of them are trying to reach somewhere on the internet to another server. So in this case here, the port number for this machine is 54116, and it's trying to reach out to this machine at this IP address running a service at port 443. So you can view this as a house which has got an address, IP address, and within the house we have multiple occupants. Each occupant is different from the other. And on the right is also another building which has its own address, and within that building you have another few occupants, each providing different services. So that is the reason why we need to have port numbers. IP address alone is not sufficient. IP address can only identify the machine, but you also need port numbers to identify the service which is running on the machine. Which service do you want to connect to? So that's all for this background on networking. Thank you for watching.